Okay, earlier we talked about checking the primary ignition system trigger on the HEI system. Now, we're going to use that same technique from the points. Now check out the build-up here. We're going from the points, HEI, now we're going to a more advanced system. If you pay attention, they all work the same way. Okay, it's just a build-up from year to year. But the concept is the same. Different parts, the same concept. Let's take a look. Here's a 4-cylinder Eagle, right? Ignition circuit. We have the distributor, which has an RP. What we're looking at here is a 4-cylinder Amigo, a little more advanced ignition circuit. We have a distributor that has 2 sensors, RPM and position. You can see here, these 2 wires are ground. If you look at it, you follow it. You got a ground circuit here and ground going to the ALDL. Okay, it's kind of strange. You got another ground wire here. It comes off the same line as this place. Strange. We also have an RPM signal. Input into the PCM. Then position sensor. Cylinder position. Reference voltage input. We have the coil. And look at the coil. Just like the older ones. Got a power. You see here, follow this line. It's going to a fuse. Fuse number 9. So the voltage goes in this terminal and out to the ground side. Remember, this is the trigger. You can see a splice here. So we're going up to something called a power switch, which is actually the transistor. ICM. The transistor inside this. And this side here goes up to the PCM. So basically what's happening, that's everything, yeah. Here's your transistor. Your transistor is actually inside this power switch. Here's the base collector, which is this side. No, I'm sorry, collector, which is this side. Emitter, this end. That's the emitter. And the base, which is here, will be sitting inside. Well, the whole transistor is sitting here, but the base is the control. Did I say it right? Let me say it again. The transistor sits inside here, inside the power switch. Okay. We have the emitter. I think I said it right. Yeah, it's the emitter. The collector. And the base. I'm pretty sure that's right. But anyway, I think that's right. But anyway, this transistor is sitting in here. Kind of confused. I'm trying to picture it for y'all. I'm trying to draw this picture for you. The load. This transistor is sitting in here for this power switch. This is the coil, the power coming in, right, to the coil. That's your load device. That's your emitter, controls the ground. This is the base that controls the switching or turn on off the transistor. So how this works is, once the computer receives an input from the crank sensor and position sensor, the module, a PCM, was send a digital squirrel wave down here to the base of the transistor. The transistor will trigger the emitter off and on, which fires the negative side of the coil, which ground and unground the negative side of the coil. When it does that, we got spark out the coil to the distributor to your spark plugs. Now, if we ever have a situation we had no spark and we have a trigger here, that means all this stuff is working. Either we got a bad coil or a bad coil wire. Just like the HEI circuit we did. Again, we have a car, say this car had no spark, and we're testing negative side of this coil with a test light, and it blinks. That means we have a trigger. So the problem would be a bad coil or coil wire. But if we go to the negative side of this coil and it did not blink, we have a triggering problem, a wiring problem. Either bad transistor, no input to the PCM, or PCM not sending a signal out to the base of the transistor. You can see it gets a little bit more involved. But now look at this. This is how we can figure out what's going on. Okay, the top trace, your top trace is the reference signal to the distributor. Right, so this top trace here is your reference signal from the distributor to the PCM, which is this one. The next one is your crank signal from the distributor to the PCM. So that signal goes in here. So it comes from the distributor into this terminal over here. The first one from distributor into this terminal over here. Right? So your position sensor here, your crank signal here. Now this one is these two here. We talked about this earlier. This is the low amp probe around the coil wire, either negative or positive. Which is wrapped around this wire or this wire. Not both wires go to cancel out. Either or, doesn't matter. We're seeing the current run through the coil. As you can see, right? The current is running about a little less than, it's about 5 amps. If you go across here, it's about 5 amps. This now is the primary trigger. This is the primary trigger on the negative side of the negative side of the coil. It's the voltage trigger here. So you have the transistor off. As you can see, 0 amps, like we talked about before. The transistor going to ground. Dwell section is charging the coil. That's how you see the current running through the coil here, like we talked about before. You see all this stuff to relate again? Here is when the transistor turns off. You get the primary spike, and you can see it. You can see the current fall back down to 0 because it just turned it off. Got your spark line, right, and your coil oscillations. So, if we didn't have a trigger, we had to check for these signals here. Well, you're missing one. We're missing this one. This is the one that triggers the transistor. Okay? So, think about the flow here. The distributor rotates. We send these two signals, two sensor inputs here and here to the PCM that we just went over. The PCM receives those signals. Now the next step is to send a square wave signal to the base of the transistor, which is going here and down into the transistor, the power switch, which is where this transistor is located at. And here's the base. Remember, the base controls the triggering of the coil. We need a positive voltage on the base. Remember, we talked about that. And here's the signal. Position, amperage, voltage triggered. Now we have a modified squirrel wave. Little oddball, but it's a squirrel wave. On this end going up here, that's the positive side that triggers the base of the transistor. When it falls down, it turns the transistor off. Again, the rising edge here, positive, turns the transistor on to charge the coil. The falling edge turns the transistor off to fire the coil. When it comes off here, it fires the coil. Now you understand the build-up here. You just seen the walkthrough how this ignition circuit works. So if you had a car with no spark, these are things you would check for: a trigger, coil wire, inputs, and how those signals are supposed to look after it's fed into the computer and coming from the computer. I hope that makes sense. If you have any questions, let me know. Peace, I'm out.